Okay, we're going to take a little time and look at how to simplify square roots. And so what we're doing now is not just looking at perfect squares where we get it down to, oh, I know what the square root of 81 is. We're looking at ones like 24 that won't pair all the way out. So a couple things to remember when we're looking at this. If I said, for instance, x times x equals 25, and we were trying to figure out what x is, I'd be figuring out what multiplies by itself to equal 25, which should be just 5 and 5. So x would be 5. That's the same thing as saying x squared equals 25. And so saying what number could I square to equal 25? Or the way we're looking at it today, x equals the square root of 25. So all of these say exactly the same thing. You're going to see it this way. More than likely, you're thinking about it like this: what multiplies by itself to get 25? And the way we'll split it up is to say, we'll split it up like that first way and say, well, 5 and 5 are what multiply together to get 25, so x would be 5. I think up here, just as a guide, you've got your perfect squares, but we're going to take it and split it apart down beyond the perfect squares just so that we can find pairs, and whether or not we realize it's a perfect square isn't going to matter, because if I get the pair of two numbers, then we're good to go. So looking first at 81, I know 81 can split up into just 9 times 9. Okay? And you probably already know, oh, the square root of 81 is 9. But the way that we talk about it here is that once I find a pair, that pair joins together and moves outside of the house. So the way I kind of remember that is you've got numbers in here inside a house party, and while that party is going on, they get split up into some different groups. But anytime you have two numbers that are the same, they're going to get together and they're going to get married. And when they get married, they go outside away from the house party. And so they're married, they leave, and two become one. So every group that I get turns into just one of that number. So a group of nines would just be 1 9 on the outside. I don't need the square root symbol because there's nothing that's left on the inside. Okay, when I look at number 2, now it's 2 times the square root of 484. So I'm going to start out just by putting a 2 here, just because whatever I get is going to be multiplied by 2. And then when I look at 484, there's a lot of things that I could look at to split it up by. You might only see that it divides by 2, or you might say, oh, that's a 4 and 8 and a 4, so that would divide by 4 to get 121. Either way works. Since I don't have any pairs, I'm going to see if those can be split up. 4 can be split up into 2 times 2, which gives me a pair, and as soon as I circle that pair, it's going to come outside to multiply by that 2. And then 121 is 11 times 11. So as soon as I've got that pair, or that square root, it's going to move outside. And then I end up with everything pulled apart because 4 and 121 are both perfect squares. All it's left to do is multiply those together. So 2 times 2 is 4. 4 times 11 would be 44. And that's not one of our perfect squares up there, but 484 would be the square root of 22, just because 2 times 11 is 22. Then we get down into numbers that don't necessarily pair all the way up, but we can split those up and use the same process. So for 24, you might say 6 times 4 is normally the one we think of to start with. But you could also say, well, I also know 24 could be split up into 8 and 3, or 24 could be split up into 12 and 2. And so, however you split this up, it's all going to work out the same. So, because I don't have a pair yet, I'm going to split up 6 into 3 times 2 and 4 into 2 times 2. So now there's no way I can split those up more. If I were to split that up into 3 times 1 and 2 times 1 and 2 times 1, yeah, I'd have some pairs of 1s, but 1 times 1 is still just 1. And I really could keep on going forever with pulling 1s out of the number, and it doesn't really help me any. So I'm just looking for factor pairs that aren't 1. So for instance, here I've got a pair of 2s, and it doesn't matter which ones I circle, but there's one pair of 2s, so that's a 2 on the outside. And then everything that's not paired up, so the 3 and the 2 here, are going to multiply back together and move back inside the house. So that would be 24 is 2 times the square root of 6. And over here, when we look at, if I'd split this up into 8 times 3, that's 4 and 2. 4 is 2 times 2. So I'd still end up with a pair of 2s and then a 2 and a 3. And same with 12, split up into 3 and 4, or 6 and 2, and 2 and 2. And I'd have a pair of 2s, a 3 and a 2 left over. So you don't have to worry about which pair you choose, as long as you've got 2 numbers that multiply to get this number up here, it's all going to work out. And then we move on to ones that have some variables in it. So looking at the square root of just 8 to start out with. I look at 8, it splits up into 4 times 2, and 4 splits up to 2 times 2. So I have a pair of 2s, and I'm going to put right outside right away. Then I have this x to the third power. And so remember that if I did x times x, that's the same thing as x squared. Just like 2 times 2 is the same thing as 4. And 2 times 2 times 2 is the same thing as 8. So x to the third power would be the same thing as x times x times x. And so whatever my exponent is, that's just how many of that number I'm going to list out, or that variable I'm going to list out. And I'll circle up my pairs. So I have a pair of x's, means 1x, because those pair come together and make 1. 1x moves to the outside. I've also got a 2 and an x that didn't pair up, so those are going to move back inside. So looking at that, 8x to the third power would be equal to 2x times the square root of 2x. Then, when I've got a number like 32 down here, I'm going to split it up again into whatever we think of. Normally we do 8 times 4, but if you said 16 times 2 works as well. So 8, if I split 8 up into 4 and 2, one of the things you notice is I get a pair of 4s right there. So I could stop right there and get that as a 4 and 4. But let's say I've already split it up into 2 and 2, 2 and 2. That means is I've got 2 pairs of 2s. And so it'd be a 2 times 2. And it moves to the outside because there's 1 2 from that group, 1 2 from that group. Then I have 2 x's, which just make a group. And y to the 5th gives me 5 y's, which would be 2 groups there. So you can put 2 y's, which is really just y squared. Same thing as if I had two groups of twos, I could make that 2 squared would be exactly the same. And let's not forget, over here, there's a 2 that was left out. Over here, there's a y that was left out. So those go back inside the house as 2y. And I didn't multiply that together yet. So let's go ahead and do that, and we'll have our final answer. 2 times 2 is 4. So 4x y squared, the square root of 2y. Our final answer there. So as you're splitting it up, it's all about breaking it apart into smaller pieces, finding things that pair up, and putting whatever's left back inside that radical. So good luck working on that, and you'll do great with it.